So now we're going to talk about an idea called closed form. So if you have a summation with a variable number of terms, so it's not fixed, is shown to equal an expression that does not contain an ellipsis, the ... or a summation symbol, we say the sum is written in closed form. So you have to be able to write your summation where you have a variable number of terms without an ellipse or without a summation symbol. So we've actually already seen an example of this. In our last video, we proved this formula by induction. So if you see on the left here, I have a variable number of terms. It's not always the same amount. And if I look on the right, there's no ellipses, there's no ... and there's no summation symbol. So this, I could say, this formula expresses this variable sum in closed form. And what's really nice about having these equations, these formulas in closed form, is that it allows us to easily do some computation. So let's look at some problems. Let's say I want you to evaluate 2 plus 4 plus 6 all the way up to 500. Now remember, we want to do computations in an efficient manner. So here I don't want you to pull out a calculator and add up these numbers, 2, 4, 6, all the even numbers up to 500. That wouldn't be an efficient use of your time. So what you're going to do is, I notice we said these are all even. So what I can do is I can factor out a 2 out of all of them. And then they become consecutive integers from 1 to 250. So what I can do is use my formula, my closed form up there, where n is 250. So you're going to go back up here to this formula and plug in n equals 250 to calculate the summation. So this will be 250 times 251 over 2. The 2's will cancel. So this is 250 times 251, or 62,750. Let's look at another example here. Let's evaluate 5 plus 6 plus 7 plus 8 all the way up through 50. Well, this is almost what I can use the formula on. So if I take 5, 6, 7, and 8 all the way up to 50, what numbers am I missing to use the formula? I'm missing 1, 2, 3, and 4. So I can add them back in, but then subtract them away. So I haven't changed anything. It's still the sum of 5 up through 50. But now I can use my formula on this first term here. So here n is our last number, n is 50. So you're going to plug that into the formula. It'll be 50 times 51 over 2. And then just add up 1, 2, 3, and 4. That's 10. So this will be 25 times 51 minus 10, or 1265. Let's do one final one here, part C. For an integer n that's at least 2, let's write 1 plus 2 plus 3 all the way up through n minus 1 in closed form. So here I am still adding consecutive integers from 1 up through, and now it's going to be n minus 1. So take your formula that we've been using and replace n by n minus 1. So n minus 1 times n minus 1 plus 1 over 2. So this is n minus 1 times n over 2. That would be the formula for this closed form for this summation.